In this video, we are going to take a look at the idea of continuity and how it relates to limits. So, the idea of continuity, from a very intuitive point of view, simply means that I can draw a line without lifting my pen from the paper, and it is completely smooth, all right? So, there are no holes, there are no gaps. Okay, it is a completely continuous line. So here's an example of a hole and another hole and another hole. All right, and so it's customary to draw a little circle around the holes just to make them stand out. So here is a function, whatever the function is, I don't know, but it has holes in it. These are holes. Boom, boom, and boom. So it is continuous. And that's very, intuitive. It kind of makes sense, right? This is continuous. I drew it without lifting my pen from the paper. Well, there's another type of way that function cannot be continuous, and that's if we're coming along here and suddenly, whoop, we have a big jump. Okay, so we jumped from here to here and from here to here. This is not quite the same as a hole, right? So we went from this point right here to this point right here. That is called a gap. And from here, going right down to here, these are called gaps. And it is not, that's a gap right there, and that's a gap right there. And it is also not continuous. So we have two ways that a function will not be continuous: holes and gaps. And so we want to take a look at each one of those in terms of the idea of limits. All right, so let's take a look at holes. All right, so when we have a function, and it is defined at every single point, such as the function f of x is equal to x plus 2. It is defined everywhere. In other words, I can let x be anything I want it to be. When x is 0, I get 0 plus 2 is 2. So 2 is the function value when x is 0. When x is equal to 3, the function value is 3 plus 2, or 5. So these are the function values, the output values, all right? And so what we get is we get a continuous line that looks something like this, all right? And so we looked at this the other day in Desmos. Here is the line x plus 2. And so we see from the table, we have when x is equal to 2, the output of the function value is 4. When x is equal to 3, the output is 5, etc., etc., etc. And so it is a continuous function. However, we have some functions that are not defined everywhere. And so if we have a function that is not defined everywhere, maybe we have a function that looks very similar to that last one, but this function is undefined at some point. And I have to draw my little hole. So forgot to draw the hole. So right here, there's a hole. All right, so the function is not defined. Whatever x value this is, there is no function value. The function value does not exist at this x value. So we put a little hole there, okay? So we saw this the other day in our last video, function number 2. Looks like this, x squared minus 3x minus 10 over x minus 5. The graph looks very similar to the graph of f of x equals x plus 2, but we notice that when x is equal to 5, the function is undefined. And so if we scroll along this graph, remember what happened when we got to 5. There was a hole in the graph. Aha. The reason the hole is there is because the function is undefined. So some functions have holes in them. Now, we want to talk about holes in relationship to limits. What do we know about the limit of this function at this value? Okay, so whatever this x value is, as we stroll along the graph coming from the left-hand side, in other words, if we take the limit, and let's just call this x sub 1, the limit of f of x, as x approaches some value x sub 1 from the left, well, it's approaching this function value up here. Okay, it's approaching some function value. And as we approach it from the right, okay, in other words, the limit of this function, f of x, as we approach, as x approaches x sub 1 from the right, it is also approaching some limit, L, okay? It's approaching this function value, whatever it is. We know the function value doesn't exist, but it is approaching that function value, which we'll just call L. It has a limit. In other words, the left-hand limit exists and the right-hand limit exists. And so we know that if the left-hand limit exists and the right-hand limit exists, therefore the limit exists. So the important idea here is if we have a hole, the limit exists as we approach that hole. The limit exists as we approach the hole. And so we can go back to our Desmos graph here. And so remember, in this graph, we have a hole at 5. There is that hole at 5. Once again, can't quite get there we go. But remember, we looked at the limit over here. What is happening to the limit? As we get closer and closer and closer and closer to 5 from the left, we saw that the limit was approaching 7. As we got closer and closer and closer to 5 from the right, the limit was approaching 7. So in this particular example, we have a hole in the graph, but the limit from the left and the limit from the right both exist. They are both the exact same number, 7, and so therefore the limit exists. If the limit exists, we have a hole. Or if there is a hole, the limit exists. Next, let's take a look at what happens if we have a break in a graph. So let's say we have a graph and we have a function, and for some reason, there is a gap. Well, as we approach this value, let's call it A. As we approach that value A, does the limit exist? If we limit of this function f of x, as x approaches A from the left, is going to be this value right here. Let's call that L1. But as we approach the limit of the function, as x approaches A from the right, which is over here, we're coming over this way now, well, this value is L2. It's a completely different function value. The function value that it's approaching is completely different, L2. So these limits are different. They are not equal. And therefore, the limit does not exist. The limit of the function as x approaches A does not exist. Well, this is typical when we have a gap. And so when we have a gap, the limit as we approach the gap, does not exist. All right, and so that's the basic idea that I want you to understand before we get into today's material. We have two types of discontinuity: holes. With a hole, the limit exists. With a gap, the limit does not exist. And so kind of wrap your head around this idea, and we will explore it a little bit more when we get into class.